guys. Didn't see you sitting there. Just practicing my fishing here in the basement. Oh yeah. Summer's on its way. We are getting so close, but hey, who's ready for a little bit more math here today? We have an exciting lesson. Not only is it math, and math is like super exciting, but this is the last official math lesson for 8th grade. So last official math lesson for your time here at St. Barnabas. It's kind of bittersweet. I know the last 6-7 weeks have not been ideal for sure for any of us, but I really appreciate all the hard work and effort and energy you've given. And you know, summer's almost here. That's super exciting. Your efforts are paying off, and you're going to get some time to relax and kind of unwind once the e-learning is finished next week. We still have some check-ins next week. We still have one assignment left, but today, the Google Doc today, is your last official math assignment. I'm going to ask you to do something a little bit different next week. Still have an assignment, not so much math related, but still going to ask you to complete one last assignment. So more details on that later, but for now, we're going to gear up for our last lesson before summer hits. It's almost fishing time. This hat actually used to belong to my grandpa. This thing's probably like 35 years old. Put a battery in it, and it's still ticking. Anyways, this is getting me kind of geared up for summer. I got my fishing hat on. Found one of my tropical shirts. Of course, got the fishing pole. Do some fishing this summer. We actually do some yard fishing in our backyard. Set some buckets up around the backyard. Just sit and cast away. That's why I got the plastic golf ball tied to the end. Practice my casting. But I'm ready for summer. I know you are, but we got one last math lesson to go through here today. Super excited about that. You definitely need some supplies. You need your notebook, a pencil. Probably don't need your calculator today. But I got my my same resources. Got my trusty whiteboard. Got the old marker. Got the magical eraser. Still haven't figured out after 7 weeks what's so magical about this. This thing has definitely seen some mileage, but haven't figured that out. But no good math lesson is complete without the old, somewhat lukewarm cup of Joe. Here's to a great lesson here today. Can't deny the fact that a good cup of coffee definitely makes a math lesson more complete. So here we go. We are almost there. You guys have run this race. It seems like it's been a marathon, but you're on the last leg. See the light at the end of the tunnel. It's that light for summer coming up, but it's also the light for high school coming up. And part of my job was to get you as prepared as I could mathematically for the classes and the skills that you're going to develop over the next 4 years in high school. It's an exciting time for you, and I want to reinforce one major hitter from 7th and 8th grade, and that's geometry. So we're taking a little bit of step away from a lot of the algebra that we've been focused on and look instead at some of those core geometry skills that we sharpened this school year. I wanted to do one last review, reinforcement of that here today in this video, specifically looking at those geometric transformations. So we're changing the figure somehow, and there's 4 major ones. We're going to review those today, hit the highlights, have you do some practice on a Google Doc, turn that in. That'll be your last official math-specific assignment for the year. That's crazy. That's crazy but exciting as well. So in your notebook, if you want to go ahead and pause the video, get down this title and objective, geometric transformation. Our objective here today, by the time this video is over, you should have a really solid understanding of how to translate, reflect, rotate, and dilate a figure. And then kind of subsequently be able to describe whether or not that new image is congruent or not. All right, pause the video if you need to. That's really at the heart of what we're going to be doing here today. And here are the 4 main types. This is just a quick review. Let me adjust the screen a little bit. Pardon me. Push that down a little bit. There we go. 4 types of transformations. Let's review these. First one, we have a translation. Transformation is like the big like umbrella statement or umbrella topic that all of these other transformations kind of fall under that broad topic of transformations. The first specific one we looked at this year was a translation. That's simply shifting or sliding a figure across the coordinate plane. And I believe when I introduced this earlier this year, I used a playing card. If I take this 8 of spades and I translate it on a piece of paper on a coordinate plane, all I'm doing is sliding it. I might slide it to the right, to the left, up, down, up and to the right. So, I'm just sliding it. It's still face up. It's still an 8 of spades. I could, number 2, I could reflect it. A reflection is a flip. So if I take this 8 of spades and I reflect it over, remember we talked about an axis of symmetry, a line of reflection? I take it and I flip it. So the 8 of spades gets not turned, but flipped. The axis of symmetry could be here, could be horizontal, could be the x-axis. I flip it this way, that's a reflection. We're going to be doing that on a coordinate plane. Number 3, we talked about a rotation. A rotation is a turn. It has to have what we call a center of rotation. It's kind of like here's a great example. This clock. This clock, the hands are rotating around, around the clock. There's a center of rotation. It's this pin that literally goes through the center of this clock, and everything rotates around it. How many degrees can you rotate around it? Really as many as you want. There's obviously 360 degrees in a circle. You could go 360, you can go 90, 270, 180, you could go 1 degree, you can go 365 degrees, so you could go more than a full circle. So we're going to be talking a little bit, reviewing that here today as well. And the last one, by the way, the rotation on the playing card, I could rotate at 90, 180, 270, or all the way back to 360, or somewhere in between. Maybe it's like a 45-degree rotation. You can go clockwise, and I'm looking backwards. I think that's clockwise for you guys. Clockwise, you can go counterclockwise. We'll be reviewing that as well. The last transformation is a dilation. Pause the video if you need to get this down. The fourth and final one is a dilation. And we kind of described it as kind of like when you go to the eye doctor and they dilate your eyes. They make them real big, right? The pupils of your eyes get real big, but they eventually shrink back down. They reduce as well. So a dilation can be an enlargement or a reduction. And we're going to review which one is which. How do we know if it's going to be an enlargement? How do we know it's going to be a reduction? It all comes down to what we call the scale factor. And you guys know from many years of math that a factor is something that you multiply. So if the scale factor that you multiply by is bigger than 1, it's an enlargement. If the scale factor is less than 1, it's a reduction. If the scale factor is equal to 1, we're going to look at that here later on in this video. All right, so that's kind of the background, it's kind of the framing of this lesson. Let me erase my boards here, get some space. If you have graph paper, great. Go ahead and take out a piece of paper or a piece of graph paper now. Pause the video and go grab that graph paper. If you don't, find a straight edge. Somewhere in your house, there's something that has a straight edge. Edge of a notebook, edge of a note card, your parents' driver's license, whatever. There's something in your house that has a straight edge. You're going to need that to create your own coordinate plane. All right, the first one I want to look at is translation. We said on the previous screen, a translation is just a slide or a shift. So let's start with one that doesn't have any units. Let's just start with a letter, just to review some vocabulary here. Let's say I have the letter A, and I put the letter A in the 3rd quadrant. And I want to translate this letter to a different quadrant. Let's suppose I want to go to quadrant 1. Which directions would I have to translate? I can go up and right, or I could go right and up. The order doesn't matter at all. But the vocab that I want to remind you of, the original figure, this is called the pre-image. And the resulting figure is called the image. So I took capital A and I slid it right, slid it up. This is the pre-image. This resulting figure is called the image. And notice I put this little apostrophe. Do you guys remember what we call that? That's right, it's called A prime. So in math, in geometry, and all of you are going to be taking geometry in high school, anytime you see an apostrophe, you say the word prime. That means it's the image, it's the result of some transformation that has been performed. In this case, it was a translation. So that's just a little vocab. But let's create a new coordinate plane. But this time, let's put some units on it. If you guys could go about 3 or 4 in each direction on the y-axis, on the x-axis, go about 3 or 4 in each direction as I get mine directions and my coordinate plane drawn. So here's the directions. Pause the video if you could. We're going to take a triangle, ABU, ABU, and we're going to translate it. So we're going to slide it 5 units to the right and 4 units down. Pause the video. Let me go ahead and get my coordinate plane. I also don't have any graph paper here, especially on a whiteboard, so I'm trying to make do with the resources that I do have. It's good practice for life, really. Make do with what you got. Sometimes it's not ideal, but that's just some of the curveballs that life throws at us. Alright, so I've got my coordinate plane. I'm going to go ahead and give you the pre-image. I want you to graph the pre-image, and then we're going to try to translate it. So let's put A at negative 2, 3. Let's put B at negative 3, 1. And C, or excuse me, U is negative 1, 1. So ABU looks something like that. I'm going to translate it. Where am I going to translate it? I'm going to go 5 units right and 4 units down. So right now it's in quadrant 2. I want you to think about where do you think this is going to land? In what quadrant do you think this is going to land? So one of the things I do want to review here quickly, because I know you're going to see it in high school. Remember talking about what's called a mapping? So a mapping, just like a treasure map, a mapping kind of takes you where you want to go. So a mapping is going to tell you where to go, like any map does, right? And any mapping is going to start with the ordered pair x comma y. We always use a right arrow in a mapping, and then the other part of this map is going to tell you where to go. So because I'm moving to the right, I'm going to add value, right, to x. So this is going to look like x plus 5. What this is, instead of writing it out in words like this, I can write it in symbols like this with a mapping. That's why mathematicians came up with this, so they can get the point across a little bit quicker instead of writing words all the time. So this is saying take all the x's and just add 5 to them. In other words, I'm shifting to the right. And then my y, since I'm going down 4 units, all my y's are going to be 4 less than what I started with. So here's our mapping. Pause your video if you need to. So literally what I'm going to do is add 5 to every x. And then I'm going to take away 4 from every y. So let's do that. That's why I left a little bit of space here on these coordinates. Let's add 5 to every x. And let's take away 4 from every y. Add 5 to every x. Take away 4 from every y. And that'll give you A prime, B prime, and U prime. Go ahead and pause the video. I'm going to do my calculations. You do yours and see if we come up with the same thing. Go ahead and pause your video. Alright, I came up with 3, -1. 2, -3. And 4, -3. Let's go ahead and graph those, see if we get a triangle that's been translated. And just like that, I get a triangle that was shifted or translated 4 units to the, or excuse me, 5 units to the right, 4 units down, and we're done. Tonight on your Google Doc, I'm not asking you to graph on the Google Doc. I'm just simply asking for these coordinates of the image. Okay, so I'm looking for the prime coordinates for this image. If you want, certainly, if you want to do this on paper tonight on your Google Doc, go ahead and do that. If you're more of a visual learner, that's fine. But on your Google Doc, I'm just asking for the coordinates of A prime, B prime, U prime. All right. Last point to make: are these two triangles, are the pre-image and the image congruent? So we got to think about, what does it mean to be congruent? Congruent means it has the same shape, definitely the same shape, but also the same size. Do these have the same size? Absolutely. In high school, you're going to calculate the area of both of these. You're going to calculate the perimeter of both of these, and you're going to realize that these are the same size, which means these are definitely 100% congruent. All right? That's good. That was about 2 days worth of instruction in the school building, shrunk down to about 10 minutes. Okay, so again, I'm just reviewing, reinforcing, trying to get you as prepared as I can for high school. That's exciting times. I am 100% confident you guys are ready for high school math. And it's only because you've been working so hard and putting forth such great effort here over the last couple years that I've had you, but I know it stretches back all the way to kindergarten. So thumbs up, 2 thumbs up for all the work that you've done. All right, let's move on to reflections. All right, let's reflect. So we'll call this example 2. Let me get the directions down. Let's reflect triangle PUA. Pua. It's my nephew's one of his favorite Disney characters, Pua, from what is that? Moana, right? Moana. Let's reflect triangle Pua over the x-axis. So there's the directions. Obviously, I haven't given you the coordinates yet. We're going to do that right now. Pause the video if you need to. Get these directions down. Let me get my other board. Reflect it. So new coordinate plane, if you could. You can get a new coordinate plane. If you have graph paper, great. If not, no big deal. Let's go, again, about 3 in each direction. About 3 in each direction. And let's go. Point P is 1, 3. U is 1, 1. And A is 3, 1. Alright, so pause the video if you need to. Here's the coordinates. The original, what we call the pre-image. This is the pre-image coordinates. There's what it looks like graphically. So go ahead and pause the video so you can get, this is kind of like the preliminary information down before we're ready to reflect it. Alright, pause the video. Alright, unpause. We're going to reflect this over the, what did I tell you, the x-axis, I believe. Okay, so here's our x-axis. I'm going to take this triangle, it gets flipped over the x-axis. You guys have the luxury of having a piece of paper. I'm on a whiteboard that I can't bend, But if you could bend your paper along this x-axis, this triangle would fold over that bend. So what's going to happen to this triangle? It's going to get flipped upside down. That's right. What if I reflected it over the y-axis? The y-axis becomes the axis of symmetry, some vocab from earlier in the year, or sometimes we call it the line of symmetry, the line of reflection. It gets flipped this way over the y-axis, so it would end up looking like that if we were doing the y-axis. We're doing the x-axis. So we know that the distance between this point and the x-axis is 1 unit, right? So if it gets reflected over, the distance now below it is also going to be 1 unit. Same with this one. This is 1 unit away from the line of reflection, or the axis of symmetry. I'm trying to do this backwards, so bear with me here. How far is this point from the x-axis? That's right, it's 3 units. So the image must be 3 units below the x-axis. It would be down here. And I now have my 3 points. It's kind of straight. I'm trying to do it backwards and looking into the screen. But you can see the triangle got flipped upside down. So P prime, U prime, A prime would be 1, -3, 1, -1, and 3, -1. And go ahead and pause the video. Go ahead and get down P prime, U prime, A prime. And one kind of pattern that I want to remind you of, if you reflect over the x-axis, notice what happened to the x values here. They didn't change, right? They didn't change at all. But, also kind of cool, what happened to the y values as I went from P to P prime? It became opposite. That's right. So I went from 3 to -3, 1 to -1, 1 to -1. So if you reflect over the x-axis, the x's don't change, but the y's become opposite. And the same would be true, but in reverse, if I had reflected over the y-axis. So that's just, again, a kind of a 5-minute review of reflections. Oh shoot, I just erased it. But the triangles look something like this. One thing I did want to point out, they are congruent. Why? They have the same shape, that's right, and they also have the same size. If we calculated the area, perimeter, so on and so forth, they'd be exactly the same. So even though they got flipped, they retain congruency. Okay? That's also a question on the Google Doc. Almost there. In fact, in the words of John Bon Jovi, we're halfway there. Getting real close. Getting real close. Keep your head in the game. We're all in this together. All right? Here we go. Example number 3. We're going to look at rotations. We're going to do this one real fast. And in fact, for this one, you don't need units on your coordinate plane. We're going to rotate the letter A. Let's rotate the capital A 90 degrees clockwise. I haven't given you what the graph looks like, but if you could get these directions down, we're going to do about 3 parts to this one. Part A, I want to rotate capital A 90 degrees clockwise. Go ahead and pause your video. You might be wondering, why does he keep choosing the letter capital A? Because it has some symmetry, but the top of the capital letter A is not the same as the bottom, so you can kind of see how it gets turned and manipulated. So if I start with capital A, just lost my eraser. If I start with capital A in quadrant 1, and I rotate it 90 degrees clockwise, so in the same direction as a clock, so it's going this way, 90 degrees, which quadrant is it going to end up in? That's right, it's going to end up in quadrant 4. But the big question is, if this is the point of capital A, which direction, up, down, right, or left, is the point going to be pointing? If it goes 90 degrees, that's right. It's going to be pointing to the right. So the image, A prime, would look like that. Good. That's 90 degrees clockwise. Let's try another one. Let's go, so we'll label this part B. Let's go rotate A 180 degrees counterclockwise. Rotate A 180 degrees counterclockwise. You might be thinking to yourself, is this a trick question? Kind of. It's not a trick question. It just gets you thinking a little bit more. Does it matter if I go counterclockwise or clockwise? If I go 180? No, not at all. Because 180 is, that's right, it's half of 360. So it doesn't matter if you go the direction of the clock or counter to that. If I go 180 counterclockwise, now I'm moving in this direction. 90 would look like that. 180 would be upside down. So the answer to part B would look like this. It would be an upside down A in quadrant number 3. Let me grab my eraser that I dropped. Gotta find it first. There it is. All right, we're almost there. Last one. What if I ask you, I'm just going to write it up here. What if I ask you to rotate, let's go 270 degrees clockwise. 270 degrees clockwise. So I'm going the same direction as the clock, so I'm moving that direction. Let's go 270. If I go 90, we said it looked like that. 180 looks like that. Another 90 would look like that. So the interesting thing, if you go 270 clockwise, that's the same as going counterclockwise. How much? That's right, 90. It's going to give you the same image. If you go 270 clockwise, that's the same as kind of negative or counterclockwise 90 degrees. Good, very good, because 270 plus 90, you got it, it's 360. All right, we are almost there. This is a good review of transformations. You guys are going to rock and roll geometry when you get to high school, and I'm so incredibly appreciative of all the hard work you've done to get to that point where you're ready for high school. All right, last official problem of math at St. Barnabas. Here we go. Example number, I think we're on 4. Last transformation. Let's look at dilations. Oh, by the way, the rotations, does it retain congruency? Absolutely. We didn't change the size or the shape. Dilations, on the other hand, we're going to keep the same shape, but we're definitely going to change the size. So dilations are not congruent, but rather they are similar. You might make a note in your notebook. If I enlarge the triangle or I shrink the triangle, it's no longer congruent, but it is what we call similar. And similar triangles are exactly that. They have the same shape. They're both triangles, but they have different sizes. And their sizes, this is a big topic from 7th grade, the sizes are definitely proportional. Definitely proportional. You know, if you look at like rectangles, for example, I got 2 sitting right here. This whiteboard and this playing card, they're both rectangles, right? Are they congruent? Not a chance. Not a chance. These are not congruent. They're different sizes. But are they similar? Yeah. Yeah, they are. They all have 90-degree angles, but their sides are not congruent. Their sides are proportional. So these would be considered similar, not congruent. So if I had, let's do a triangle. You need a graph that probably goes about 6 in each direction. So last coordinate plane that I'm asking you to draw this year. How many coordinate planes do you think you've drawn in my class over the last 2 years? Hundreds, right? You guys are like graphing experts. But if you can go about 6 in each direction, I might run out of space, but I'm going to make the best of it. Pardon me while I get this this graph done. Just stare at my grandpa's old hat for a second. All right. I got as far as I could. I went 6 in most directions. My board just wasn't big enough. But let's go ahead and start with, let's do triangle Sue. So S-U-E. I'm trying to find 3-letter words, 3-letter names to give these triangles. This one is Sue. I had a Abu, Pua, and now I have Sue. All right. Let's do S is -3, 2. Put on this board. S is -3, 2. U is 3, 2. And E is 0, -2. All right, so there's S-U-E. If you can pause the video, go ahead and get these down in your notes. Once you have these coordinates down in your notebook, go ahead and graph them on your coordinate plane. Go ahead and graph S, U, and E. I'm going to graph mine, you graph yours. So there's what Sue looks like. First thing I want to do is dilate Sue with a scale factor. Get this directions down. Dilate triangle Sue with a scale factor of 2. So we're going to dilate triangle Sue with a scale factor. Again, factor means multiply. Multiply everything by 2. If I multiply everything by 2, what's going to happen to Sue? Boom, she's going to get bigger, right? It's automatically an enlargement because the scale factor is bigger than 1. That's right. So literally every coordinate can be multiplied by 2. So my resulting S prime would be -6, 4. U prime would be 6, 4. And E prime would be 0, -4. S prime, U prime, E prime. Go ahead and pause your video. Once you have these written down, let's go ahead and put it on your graph. What should happen to Sue? Sue should get really, really big, right? Barely fits on my board, but Sue prime got really big. What if I had multiplied or dilated by a scale factor of 5 or 10 or 1,000 or 1,000,000? I can get as big as I want. Sue would become really, really huge. I can dilate infinitely many times. But here's the cool thing, and this is where it becomes kind of artistic. What if I dilated by a scale factor of, let's go change the directions a bit. Do some erasing. What if I multiplied by a scale factor of 1/2? So dilate Sue, this is kind of like part B. Dilate Sue with a scale factor of 1/2. Now what's going to happen to Sue? The original Sue, that triangle, becomes smaller. That's right, half the size of the original. So that would be -1.5, 1, 1.5, 1, and 0, -1. So there's my new S prime, U prime, E prime. It's half of all of these original values. That's right. Pause the video. Pause the video. And now let's go ahead and graph the newest Sue double prime, we can call it. And now you can kind of see why I said it becomes kind of artistic. It's kind of cool if you're into like art, contemporary art, and like patterns and sequences and how things retain the same shape but become different sizes and that like repetitive nature of it. You could sit here and dilate by 1/10th, 1/100th, 1/1,000,000th, and you'd still have this like teeny tiny little triangle that you can barely see, but it's still a triangle and still proportional to the original Sioux. Math is amazing. Math is really, really amazing. Get you some pretty cool pictures. Now, what if, last question, I promise, what if I multiplied by a scale factor of 1? What if I dilated with a scale factor of 1? The answer is nothing would happen, right? If I multiplied everything by 1, I would end up with the original preimage of Sioux. So, there you go. That's about 2 or 3 weeks of geometry instruction in 8th grade, all crammed into one YouTube video. I appreciate you guys watching. I'm so incredibly proud of all the efforts that you've made during our time in away from school during e-learning, and know that your efforts, your energy is noticed and very much appreciated. And if you haven't seen the payoff yet, if you haven't felt the payoff yet, you will when you get to high school. That's a guarantee. You will feel that payoff when you're sitting in that math class, whether it's algebra, geometry. Most of the things you're going to study the first couple years of high school, you have seen kind of the basic fundamental skills as an 8th grader. And I hope you receive that payoff in abundance, and I hope you continue to see how amazing math is as you move through high school. So we'll see you guys next week. We got one more video. It's not real math heavy, but we do have one more video. I'm asking you to perform one more task next week. But until then, if you have questions on the Google Doc from today, please let me know, and you guys are going to rock and roll it. Be kind to one another, as always. Be kind to one another. Be patient with one another. A little bit of patience goes a long way. And most importantly, continue to pray. Prayer is the perfect form of peace. And pray for our country, pray for our world, pray for your family, pray for your classmates. We all need an abundance of prayer at this point. So have a great afternoon, and thanks so much.